right, well, this is our last online session of the day. We are happy to have Dr. Jameson Hayes with us again. He is an associate professor of advertising at the University of Alabama and the director of the Public Opinion Lab. And I will say that I've known Jameson for most of my time in academia, and he has always been such a great resource, so incredibly helpful. And we have certainly looked at him a lot as we kind of create this public insight lab and help to catalyze social media research here at UNL. So thank you for that, Jameson, and thank you for sharing with us today.
Thank you for the kind words. It's been a pleasure to know you for many years and work with you over the last couple, Lisa, as well. Thank you for having me. I'm here at the Public Opinion Lab at UA, and when we were putting this together, one of the things that we discussed was, that I also serve as an associate editor for a journal, and we see a lot of people attempting to do theoretical social media research, particularly with larger data sets, but not very many of them are doing it well. So we thought, can we give some thoughts, at least our thoughts on how to do that? And I was the one picked to try to do that. So first, I wanted to give you a little bit of background on what our lab is, mostly because unlike some of the other talks today, I'm going to get a little bit into kind of what we do in terms of big data. You kind of need to understand what our lab is outside of just social media to understand the context of that. But I want to talk about I just have some general thoughts that I'm going to say that may be right or wrong, but the way I look at theoretical social media research. Then I want to go through some data, some platforms and data, some off-the-shelf software that may help you. And then I want to talk a little bit about data science and open source packages, general research design, data collection and processing things, data analysis, and then finally, kind of hopefully an interactive Q&A. We really wanted this to be an interactive session, but when so many people signed up, we decided maybe that's not the best approach. Maybe we'll just do a session at the end. So please do. I hope that I say something that sparks questions, or just say something that doesn't make any sense to you, so you have a question about why I'm a moron. That's fine too. Let's just talk at the end. I'm hoping to go around an hour and leave us a half an hour for that. So the Public Opinion Lab is our social analytics lab here at UA. Really, we analyze more than just social. We analyze anything media, mostly online. And our goals are very simple. In the communication space and really in lots of different industries, we have wonderful colleagues in computer science, and a lot of their students are taking jobs that are really communication jobs because we just haven't taught people in these other disciplines how to deal with the data. So we wanted to be able to do novel, innovative theoretical research that impacts both academia and industry, but we also wanted to, for our lab, train communications people that also understand the data. So communication-oriented data scientists, so they can do things like go work in an ad agency and understand how to design an algorithm for programmatic advertising. So that's kind of our jumping off point. So for that, we do a lot of the things. We work with the tools, the wonderful Sprinkler tools that you've heard about all day. I'm going to talk a little bit more about Sprinkler in a different context in a moment. And we can do some basic social media monitoring. We do campaign tracking, but we also do data scraping. So oftentimes our grant partners will come to us and say, hey, we need to pull this data. Can you design a custom script for us? And we do that. And that often takes us into network analysis of the data, computational text analysis. I'll talk a little bit about both of those. And we write scripts in a lot of different formats. We use a lot of Python and R. We also design API scripts both for our lab and for others. And we can do things in Bash and JavaScript. So really, whatever the data issue entails, we generally work with our partners, whether they be collaborators or clients, and design a solution that works for them. So that's kind of where I'm coming from here. So a couple of general statements. Actually, I think I have three about good theoretical social media research. One is, it's hard. It is, but it's not as hard as we make it. It doesn't have to be that hard, and the reason for that, for me, is people, if you're not familiar with working with social media data, you're like, oh, I want to get Twitter data. but we don't know why we want the Twitter data. And that leads me to the second point is people don't think about social media as just another tool. Social media research is simply that, just like an experiment, a survey. What is your research question? Is social media the correct way to answer that? Once you start looking at that and then think about, okay, well, how would I design my research if it was just a basic experiment versus I'm going to use millions of social media posts, then it becomes more into your wheelhouse, even if you're not experienced in this area. And we realize that, okay, it's just another tool. Is it the correct tool to answer my questions? Because that should always be the approach, in my opinion. Whatever the question is, what's the best way to answer? If it's social media research and analysis, that's great. If it's not, that's fine too. And then the final thing I would say is one of the most important things about doing social media research well is to understand the data. All right. So if you're going to start working on Sprinkler and pull data, make sure you go to the knowledge portal and understand exactly what the data is that Sprinkler is giving you and what it's not giving you. What are the metrics you're going to have? What are the limits of the data source? Do you have the full fire hose? Do you only have 80% of it? How many years do you have access to? All of these things are things you really need to understand before you start designing your research, or you're going to design research and then come to the point of analysis and realize, oh, I didn't understand the data. So as one of my colleagues and mentors would say, look at the data, look at the data, look at the data. Okay, with that out of the way, I wanted to first talk about some platforms and the data on those platforms. So, today we've talked a lot about Sprinkler, and I'm going to start with that. And then I'll also speak about other sources of data that you can use to pull in this different social data that you may need for your research. So, last session, Brandon did a tremendous job talking about topics. And I think earlier there was a discussion about Explore. I just wanted to quickly review and point out that there are two parts really for research purposes of Sprinkler. One of them is Explore. It kind of serves, I liken it to the Google search of Sprinkler. There's tons of millions upon millions of pieces of data in Sprinkler, and this kind of gives you a good search, just kind of a quick search. It's really good to start your research topic there because you can see generally what conversations are being had around whatever you're interested in. A basic snapshot of what that conversation might look like, and it really helps you maybe drill down on some other things. So maybe you say, okay, I want to understand, veteran suicide. Well, once I start searching, I figure out what are the major hashtags that are used with veteran suicide, who are the major influencers in that area, and maybe I integrate those into my search as well. But there are some limitations to Listening Explorer, which I'll talk about in a moment. And that's when you go into listening dashboards because you can get more in depth using that search you kind of built in Listening Explorer. And then you can do some custom things in terms of widgets. You can also put in some custom metrics that's not available to you in Listening Explorer. And that goes back again to that, know what data you have and what data you don't have. So capabilities. Well, social media listening and analytics makes sense. Sprinkler Modern Research, by the way, Modern Research is the portion of Sprinkler where you're going to do your research and collect data. There's 4 other aspects of Sprinkler that's there: modern care, modern engagement, modern marketing. 3 other aspects, but modern marketing sometimes is split between advertising and one other piece that is escaping me right now. But anyway, you can in modern research, you can do social listening, you can do some dashboard analytics. Most of the time, you're going to want to pull that data out and do more in-depth analyses for your published research. But we can look at multiple social media channels, historical and current. That's important. So we can pull things going forward for, say, NIH grants that we want to track a campaign we're running, but we can also get us historical data to analyze past events. But it all works on Boolean search. So if you remember how to search your library database, then you can search Sprinkler. Although Sprinkler does have a few bells and whistles in terms of cool advanced operators you can use. So in terms of Explorer versus Listening Insights or Listening Dashboards, they've kind of changed the name recently. So you'll see both of those terminologies referring to listening dashboards. Explorer does not have full access to all the sources that Sprinkler offers, but they do have the full Twitter fire hose. They have all the news sources that Twitter offers, the blog sources and the forums. Anything other than those four things that you find in Explorer are just they're in the system because some other Sprinkler customer searched it, but they're not exhaustive because they are based on what was searched for. So in terms of being able to say I have everything in those categories, you can't say that outside of Twitter, news, blogs, and forums. So really, if you're patient enough, anything you're doing with Twitter, you can really pull from Listening Explorer, and that doesn't count against your mentions count. The other thing that Listening Explorer does not have is engagement metrics, meaning for Twitter, it does have retweets, but it doesn't have all the engagement metrics, likes, number of comments, etc. You can pull those things from Listening Insights, but you can't get them from Listening Explorer. There's also a difference in research query length. In Explorer, your maximum query is 100 keywords. On a project I'm going to show you here in a few minutes, we had 250 keywords because it was a very in-depth project on veteran suicide. So you have a maximum keyword length. And then in terms of your dashboard queries, you also have a maximum number of 10 queries that you can put in. So, so you can build queries and then put multiple queries in, but you can only do 10 in Listening Explorer. There's also a maximum number of 10 wildcard queries. What wildcard queries are, if you have like a STEM word that you want to put an asterisk on. So if you want to look for consulting, consultant, and consulting, you can just put consult in star and it will pick up all three of those. You can do that 10 times, and you have to have at least 4 characters preceding the wildcard, so you're not pulling something super broad into the system. Okay, so in terms of listening channels, Sprinkler has 24, as you can see here. They also have 7,000 traditional sources, millions of web sources, and tons of integrations. Integrations are things that were built out, AI verticals and so forth, and data ingestions built out from their customers that they're able to integrate into the system. And then you can also, if you were working with a major company, you could use data ingestion to pull in internal data to mix with all this. All that data goes into the AI engine and spits out what we see in our dashboard if you're a typical consumer. Now, when we export that data, which most of us are going to want to do, you have 2 different ways that you can do that. Now we're in listening dashboards. The conversation stream is the base export for Sprinkler. And it has multiple things. Some things I couldn't fit on the screen, but the important ones that you want to see here is there's a universal message ID. They tell you which source it's from in terms of that's labeled social network. They have the screen name for the person who sent the post, the follower count for that person, the message itself, so the content, what type of message it is, retweet, post, Twitter update, whatever it may be, message creation stamp, timestamp, so you know when it happened, media type that's involved in that post. So Instagram, you're going to see a lot of photos and videos. They'll have retweets, Twitter likes. Notice it doesn't have a number of replies, a permalink to the actual post, sentiment, which I'll come back to in a second, and then it has longitude and latitude for where those people, from where the post was made, and if the person put it in their profile, they have the location. Obviously, people don't update their profiles, so you can decide for yourself how useful the location data is. I would absolutely suggest using filters to get data from particular locations, and also use longitude and latitude when you can. So that's part of the data. That's a good bit of data, but notice that you don't have a whole lot in the way of DVs if you want to just do basic regression analysis. So you have retweets if you want to look at particularly retweets and likes, but you don't have things for other types of social network media data. So if you have a client you're working with Facebook, or if you're pulling Reddit data, you don't have the reaction data for Reddit. This is all you're going to get in the conversation stream. However, you can actually build tables to pull in metrics from all of the different social media platforms for the most part that Twitter holds. So, here's a metrics table that I built for our instance. We have that universal message ID. We have all the Twitter metrics, all the Facebook metrics, all the Instagram metrics, all the Alexa metrics, all the Reddit metrics, all the core metrics. And then we have influencer score, sentiment, emotion, and discrete emotion. Now, all the things in red here, I want to make a note about. I'm going to talk a little bit about sentiment later. One of the reasons we switched to Sprinkler from Brandwatch is because we did an academic paper, which I'll show you a little bit about later, that shows how difficult it is to measure sentiment, particularly with AI models. I have sat down with the CTO and I felt most comfortable with Sprinkler, but I haven't actually I haven't done a content analysis against the AI to say I know exactly how effective it is. So that being said, I just caution you to about trusting any AI variables, which we'll talk about later, from any company before you take a look at it yourself and know how accurate it is. The reason I highlight Facebook metrics and Instagram metrics is through no fault of any system, the same is true across most, actually all social media listening platforms. Access to Facebook and Instagram data is limited. That is because of, well, Meta. It's because of Zuckerberg. A few years ago, Cambridge Analytica happened. I think, Jeremy mentioned that earlier in another session. And Facebook's response was to shut down all access. There is, I'm going to show you something CrowdTangle later, but now they've shut down CrowdTangle access for the moment as well. So what that means is any Facebook data you see in Sprinkler is based off of authenticated accounts that someone had a client and the client has put that data in there. So it's not representative whatsoever. So know that Facebook and Instagram is going to be really tough to do any sort of research on with any social media listening platform, and Sprinkler is true to that as well. Influencer score, sentiment, emotion, and discrete emotion, those are all AI-based models. These are not data that come directly, obviously, from Twitter, Reddit, etc. They're columns that came from the AI algorithms that Sprinkler designed. So you need to test those and check them for accuracy before you try to use those as variables in academic research. Now, that's Sprinkler, but there's other data sources. I just mentioned CrowdTangle earlier today. I hope that you could hear most of that. As I was having some connection issues, I showed you a study where we used CrowdTangle data to pull down Instagram influencer videos, and then we analyzed those data using both in our lab, but also in the biometrics lab using facial expression analysis to look at Facebook and Instagram public accounts and business accounts. CrowdTangle is one option there, and I'm going to quickly show you. It's here. The website is up. Here's the problem. Currently, because of the Meta transition, they have shut down the CrowdTangle team. CrowdTangle is a platform owned by Meta, owned by Facebook, that they use to open up access to academic researchers, but they're not allowing new accounts right now. You can pull down Instagram and Facebook data from public accounts and also business accounts, which is what we did. However, right now, if you don't already have an account, you can't really use it, although it's still live. So if you know someone, for example, our lab has a CrowdTangle account, you can reach out to them, but you're not going to be able to get data, any new accounts as of right now. Hopefully Meta will open that up pretty soon. The Twitter API is another really good resource for data. Twitter just opened the academic research API to its fullest extent last year. What it allows is for academic researchers who apply and are accepted to pull up to 10 million Twitter posts a month from that account. This is very huge for us because, with Sprinkler, we're on a mention count. Any projects that we have millions of tweets with, which you'll find that in most social media projects, tweets end up being the biggest part of your mentions haul. We go out and pull that with Sprinkler to save ourselves mentions so we can pull everything else in, we pull that in Twitter API so that we can save mentions in Sprinkler and pull everything else from Sprinkler. So that tends to be a good way to do it. You do have to be able to use a basic Twitter API. That is not all that difficult to set up. The Twitter developer tool makes it very easy, even if you're not a data scientist. But if you want some tips on that, we often build those for clients, and we're more than happy to talk with you about that as well. There's also, for all the different social media platforms, there are various APIs that you will find. So this is Rapid API is a website that lists a whole bunch of them. And you can find those, and you can find the documentation. Here's what I would caution on that. As both a researcher and an editor, you should know that if it's not an official API, you may have trouble publishing, because one of the first things I'm going to ask if someone sends in something from Instagram is, did you get permission? Because I know that if you look at the permissions from Instagram, they do not let you scrape. Now, there's a bigger conversation that we can return to on ethics, which is, if you consider Meta an unethical company, why would you follow its ethics policy? But that's completely dependent on how the reviewers and the editor feel about that. So be careful and understand what you're doing, and really think it through before you use an API that's not an official API of the social media platform. And then for all other things, there's custom scraping. Every website on the web has something called a robot.txt file. And if you put that at the end of the URL, it will tell you what you're allowed to scrape and what you're not. And so for example, if you go to Facebook, it says you're not allowed to scrape anything. Other places will say you can scrape X but not Y. And as long as you follow those rules, you can develop your own scripts to scrape that for the web. We do it quite a bit for grant projects and for commercial clients that need that. So that's the other option. So there's lots of options to get data. However, not everyone has data science capabilities, and that's growing. People are more and more, like 4 years ago, I learned R and Python. I was strictly an experimental, experimental, your basic methodologies. And I decided, hey, if I'm going to be serious about doing social analytics research and be able to credibly run a lab, then I need to learn this. So I did, but you can develop using just the data you export from Sprinkler or like social media analytics. If you think it through, you can do social media research that's theory driven with just that data you export. And here's a great example. I'm going to give a few examples throughout. In this particular example, we were interested in understanding how a brand's involvement in a social cause impacts the cause in terms of impacts engagement with that cause. So what we did was we used Mean Stinks, which is a secret campaign that ran for 5 years, wherein Secret entered itself into the cyberbullying, the anti-bullying campaign for children. My apologies. And in doing so, we wanted to understand, once Secret entered, did it hijack the campaign? Did it help grow the cause, or did it hurt the cause? So our big thing was, did the brand engagement have a deleterious impact on the long-term engagement with the cause? So what we did was collected data from Twitter, and we pulled data. We had to kind of build our data set. So we pulled data from Twitter, from the product, from the brand itself, and from the campaign accounts for Mean Stinks. And then we conducted open coding to understand what are the keywords that attach to that campaign, what are the words you use when talking about the campaign, and what are the hashtags that are used. We use those to then collect a random sample of the data from the campaign, and harvested 6,188 different accounts that engaged with the brand and the campaign. From that, we then went in, we needed 2 data sets. One data set needed to be campaign specific. So posts that were actually talking about the campaign. And then we needed a data set of posts that were not campaign related, but still talking about the anti-bullying cause. So we used those accounts to scrape those 2 different data sets. We ended up with 22,000 and change in terms of campaign specific posts, and 122,000 and change of non-campaign specific posts. So our measures, just from data we exported, ended up being campaign specific volume and campaign specific duration, post campaign anti-bullying volume, post campaign anti-bullying duration. And then we had moderators and covariates also derived from the same thing. We used this data and did a simple hierarchical Poisson regression. And as you can see here in the image, what we found was that while the brand did indeed bring new people to the conversation, the people who were most invested in the conversation died out. So the overall cause conversation was hurt in the end because the most connected people to the cause felt like the brand hijacked it, and the secret actually hurt the cause of anti-bullying conversation on the web by being involved. So that all very simple data export in this data analysis at that point. There are some off-the-shelf things that can help you go beyond just pulling data from Sprinkler and analyzing it. These are things that are pretty cheap. As a matter of fact, I can tell you the price for each of them. But they allow you to analyze that data that you pull at a deeper level without having programming knowledge. So one of the ones that are that's most popular, very well used in communication research, is LIWC, which is linguistic inquiry and word count. LIWC is a dictionary-based tool that is a computational text analysis tool. So you can pull the tweets, for example, or whatever posts. You can just pull the message column of Sprinkler, put in LIWC, and it's going to go through and scan each of those messages based on their dictionary for the psychometric value of words. All right, it's going to analyze it based on the dictionary that they've validated very well. They actually just released LIWC 22, which has updated dictionaries that include social language and a more robust emotion dictionary. They have 48 different psychometric categories that they analyze, and it provides indices for each of them, as well as some omnibus variables. So what it puts out for you is a psychometric analysis of proportional data that you can then use as IVs and DVs in your research. So these include some summary dimensions. The summary dimensions include things like sentiment, authenticity, tone, etc. They'll count things as simple as punctuation marks and function. There's good articles on what each of these things mean, but the ones that I use the most are things like the extent to which the conversation is affective versus social in nature versus cognitive, the extent to which it's talking about drivers or motivations for why people are saying what they're saying, and also time orientation. Are they focused on the past, present, or future? But all of these things become continuous proportional variables that you can put into your models. Lexamancer is another off-the-shelf. Oh, by the way, LIWC for 3 years, you're looking at $130. So it's a very small investment. Lexamancer is a little bit more. I think it's $1,500 for 3 years, but it's also a very well cited and very well published software that does a little bit more. It basically is a computational qualitative analysis tool, just qualitative but uses quant. So what Lexamancer does is takes the corpus of data, it scans that data, and produces the main concepts and a conceptual map of that data. More specifically, it scans it once for semantic extraction, meaning what are the concepts that we keep seeing co-occurring, reoccurring in the data, and it's done based off co-occurrence. So these two words keep being used together, keep co-occurring. They're a concept. What does that concept mean? They scan the data again and say, here's how these concepts relate to the other concepts. And statistically, they build a conceptual map for you. So for example, this is an example of Romeo and Juliet being ran through Lexamancer. The 5 important things it gives us are the main concepts, the relative frequency of those concepts, how often they co-occur within the text, the centrality of those concepts to the conversation, and then finally thematic groups. So for example, you look to the right of your screen here and you'll see that you have all these concepts inside of each of the circles, but you see the main concepts at the center of the circles, and then you have those concepts derived in themes and how they kind of relate, love and death, how love and death relate to Romeo and Juliet, etc. One example of how this has been used, this is a project where we were interested in understanding how people use Reddit to have discussions about oral health care that they don't want to have with their dentist, or they, for some reason, can't have with their dentist. So we just pulled some data from the social media listening platform we had at the time, and we ended up collecting from the subreddit Our Dentistry on Reddit. We collected 208,000 roughly posts that happened from about 1,300 unique monthly users over the 4-year period. We ran it through Lexamancer, And we're able to find the concept map that you see here. So you can see all the concepts that make up the major themes that we ended up deriving, which was advice and discussion about self-care and decisions, disclosures of symptoms, and oral health care practitioners and interpersonal communication. Our big takeaways here was, well, that online communities such as Reddit can supplement what the dentist conversations that the dentists have with their patients over ongoing dental concerns, advice from others about self-care, and also how to actually communicate with the dentist when you're scared of the dentist. So we found this to be, in the article, your argument was this means it's potential for future interventions for NIH type work, where we can use Reddit to assuage people's concerns about the dentist. So I said a lot thus far, but thus far we haven't done any data science, right? We can do good theoretical social media research that's published. Well, I'm sorry, I shouldn't call it. I was on those papers. It was published. You can decide if it's good, right? But we haven't written any code yet. So you can do all this without having to write code and publish. But man, it's a lot cooler when you can write code, because let me tell you, I learned 4 years ago, and all of a sudden my tool sets open up and I'm doing things I never thought I could do before. And it's just been, I've began to learn again, which was kind of cool. Anytime I can get a McConaughey meme into the presentation, I'll do that. For Texas people, you should appreciate that. So data science and open source packages is how you can then take that data and analyze it differently to actually help build variables that can become your theoretical concepts that are in line with the theory that you test all the time. To do this, the two major languages you'll want to take a look at are Python and R. There's tons of online resources for learning R and Python. The websites give you a good start, but things like DataCamp and a few other online things can kind of walk you through. And I'll just say this as someone who, when I started learning to write, I didn't think that I would be very good at it, and I probably still am not, but I'm functional. The thing I would say is, if you can get that through that first step, it's really learning enough to be able to Google what you need to do from there on out, because someone has done it, and there's a huge help site called overstack.com that once you get through the basics, you can say, okay, I need to do this. Let me Google and see if someone can tell me how to do it, and you'll be able to do it quite well. But two of the bigger things, so we can't talk obviously about all the different packages. Two of the bigger things people like to use open source data science for is sentiment analysis, and the other is network analysis. So we're going to talk about each of those. So the difficulty with sentiment analysis is, well, we have different cultures. We have sarcasm. We have different dialects even within the US. We discussed this earlier. And sentiment analysis involves training an algorithm to say when so-and-so said this, they were being positive. Well, that's kind of hard when you have different countries, different dialects, different languages, and sarcasm. So if you look at the research, what it will tell you is, even the best package, the one that's most cited in literature, which is Vader, is about 80 to 85% accurate, which obviously doesn't meet our 95% threshold. We just know that we have to consider that a limitation. One of the reasons I switched from Brandwatch to Sprinkler is we did an analysis of Brandwatch's AI and how it predicts sentiment against human coders, and they got polarity, which is positive, negative, neutral, right exactly 32% of the time. So literally just rolling a dice would have got them randomly 1% more. So obviously we couldn't stay with that platform. And also they weren't very happy that we published that. So that was one of the reasons we switched. I feel very good about Sprinkler. I would just always say, test anything before you use the AI related variables, and sentiment is one of the most difficult things to get right. So be careful. Now, if you are venturing into to data science and you want to know some packages, the two most popular are Vader and TextBlob. The paper that I list right here is a very good paper from the folks in the Netherlands that does a good job of kind of showing here's what manual annotation versus crowdsourcing versus dictionary approaches like LIWC versus machine algorithms look like. They test Vader and they give you some good info. TextBlob is another one that people use quite often, but frankly, just because I don't want a reviewer to say, how can you defend TextBlob? It's not as well published. I always go with Vader because at least then I can say it's 85% accurate. Now, here's not an example. I just wanted to make a note for you. This is a paper we did where we actually tested the sentiment AI for brand whites, used to be Crimson Hexagon, and that's the one that was 32% accurate. So make sure that you're very careful when you're doing sentiment analysis. Don't just take the stock column, even though it says positive, negative, neutral. You have the data. You can't trust it until you take a look at it yourself. The other big application that we use quite a bit, and a lot of people use data science for, is network analysis. Obviously, in social media, we want to understand how the information flows. The way I conceptualize it, by the way, is everything we looked at earlier, LIWC, Lexamancer, and sentiment is about the content. Well, we also need to know how that content flows. So if we have those two together, we can say, here's what's being said and here's how it's moving through the network. Then you have a full holistic view of what's going on. So network analysis is used to identify the different roles of different people. So who are the hubs, who can get to the most people, who are the people who are the shortest points between two people, who are the people that can get to very particular people in the network, and also understanding the flow throughout the network. So what role does each of these people play in getting us to where we want to go? So you have some off-the-shelf stuff like Node Excel that a lot of people use. I know Jeremy mentioned that earlier. We actually teach our master's students that, but Node Excel has some very big limitations in that it's very easy to pull down data and do some network analysis. But once you get past, I think it's 100,000 or maybe even lower than that, you have some pretty serious data restrictions. So you're not going to be doing an 1 million post analysis using Node Excel. For that, you'll need open source packages such as tidygraph or iGraph. This image right here to your right is created by iGraph. So they downloaded the information, downloaded the data, developed the network analysis, and showed the image. Now, I will note this. Oftentimes, we use a lot of network analysis in our lab. We hardly ever actually make a graph. And the reason is because what we're interested in, with all these nice graphs we have, there's also back-end statistics, centrality, betweenness, degree centrality, cohesiveness of the network, density of the network. What those things, we can use those to say, okay, here's another continuous variable that we can add with the continuous variables we created with the content, and we can actually build a model that says, based on where this person is in the network and the type of language they use, here's the impact they're having on engagement. So that's what I mean by, while we maybe start off, we didn't have conceptual variables we can look at, we've processed the data in a way that we're creating variables that can then be used to test theory. Okay, so an example of this is great. Dr. Brian Britt led this paper. That dude is brilliant. What we're interested in, we have a long-term project that we're interested in understanding how we can use social data science to understand the veteran suicide conversation online, hopefully identify the people who are most at risk at committing suicide, but also understand who are the people that can get those folks information, and how well is the Veterans Administration doing at speaking to those people. So we've actually collected a pretty big data set. This one only looks at 2011 through 2019, through 2018. We actually have 2011 through 2020 now. So in this situation, we wanted to say, okay, can we create a metric to identify the people in the network, not that are the shortest distance between 2 points, but the shortest distance particularly to the people who are most isolated. So who's the best person to talk to if I want to get the people that don't have as many connections in the network? So we collected over 1 million posts over 7 years. We did a natural language processing step to make sure the posts were relevant. As you can imagine, if you have a study on veterans, then you've got a lot of irrelevant posts you got to filter out. MLB veterans, vets. If you say vets, people are talking about veterinarians. So we had to do a process where we actually use NLP to make sure everything was relevant. Then we use network analysis using Python to develop an omnibus network, which is a network that's based. First, we did a reply, a mentions, and a tweet network, and then we combined those networks into one big network. And then we identified the people who are isolated in that network. From there, we created a metric that's a new network metric called targeted between us centrality. And that metric we use to identify the opinion leaders that are best situated to get to those people isolated in the network. So when we run a campaign, we would reach out to those folks first. Okay, so in terms of actual research design, first, I would say you need to ask yourself a question. And that question is kind of back to what we said earlier. Is social media data really the correct data to use to answer the research questions? Because if not, you're wasting your time, right? So assuming that it is, and so you have to say, okay, what is I'm trying to answer? What's the theory I'm trying to test? Does social media data, is there data there to use to represent the concepts that I want to test in my hypotheses? Am I going to be able to actually do this with the data I'm looking at? So make sure that's the case first. So then say, okay, what platform do I need? Is this something that makes sense on Twitter or Facebook, right? So if you're looking at, for example, we're currently working on an NIH proposal where we need to develop the keywords that people use talking about the different ways people talk about gender identity. So the moment we put in keywords, we're actually limiting the different ways that people may be talking about gender identity. Instead, we can't use Twitter. We have to use Reddit, where we can have a big conversation about gender identity and mine that for those keywords. And then we can use those keywords to look at Twitter. So is the platform I'm using correct? What is the type of user that I'm trying to get? Am I trying to get businesses? Am I trying to get everyday people? Can I identify those people in the social data? What is the data structure? Does the data structure, in terms of what variables are there and how they're composed, do they allow me to test the theoretical concepts I'm looking for? What timeframes do I need? And finally, what are the audiences? Every social media platform has a different audience. So if you need to make sure that you understand how representative or not representative that audience is to the wider group. How do these data represent theoretical concepts? So a lot of people use proxies and a lot of people use really bad proxies. So you're reading the article and you're like, all right, we use this measure to account for this. And you're like, well, that doesn't make any sense whatsoever. How does a hub in a social network necessarily mean that they're the best friend of the person they're talking to? It doesn't. So make sure that your proxies that you're using, if you're going to make them work, but more appropriate, if you can, use different techniques such as LIWC, et cetera, to process the data in a way that you can then say, I can develop more theoretically sound variables that actually connect to the theory. Then you're going to be in much better shape. And then finally, how will those data be analyzed? Right? These are all questions that you need to ask before you start actually collecting data, because if you can't answer these questions, you're going to hit a roadblock at some point. So that's just my thoughts on design. Now, in terms of collection, we've talked a lot about constructing the query. They did a great job earlier talking about Listing Explorer and building queries and topics. I would say a few things. In terms of constructing a query, first, be exhaustive. The moment if you miss a keyword, that means you missed part of the conversation, which means you're not completely representative. This is difficult. It really is. You really have to think through these things. You have to, as Dr. Kelly Smith said earlier, there's a lot of trial and error sometimes. And then sometimes you simply have to say, I have to do an entire research study just to get the keywords right, which I'm going to show you in just a second we had to do for the Veterans Research Project. You have to balance inclusivity with exclusivity, meaning you need to you need to have the keywords there that includes the entire conversation, but at the same time, you may be limited because every time you add a keyword, you're making your potential mentions bigger. So you have to say, all right, how much data do I need? But also, if you add that keyword, is that keyword a vague keyword that could bring in irrelevant data that I need to exclude? So it takes some time. I would strongly suggest, though, if I think they spoke a little bit earlier, go back and review if you're using Sprinkler, the operators, the advanced operators. There's some really cool operators you can use to really narrow down and make sure you're getting here. Beyond just the and, or, and not, you can use a lot of different things to really narrow down and get your data exactly what you want. I think Dr. Boatwright gave an excellent talk on that earlier. Now, once you have that data, then there's data processing. And as good as you may have, as much time as you may have taken, and as well as you may have done in constructing inquiry, if it's really particularly funded research, you're going to want to make sure that everything in there is relevant, because the last thing you want to do is to give a presentation and pull up Sprinkler and show the post, and you're like, hey, that has nothing to do with what you're talking about, and that's going to call into question your entire program. So natural language processing is the most important way to do that. Typically, that involves a supervised step. So you take your data, you take a sample of that, you have coders code that, you use that to train the algorithm, you then test the algorithm, apply that to a larger data set, and filter out irrelevant posts based off of that supervised step. Network analysis is, once you actually have the data, is somewhat easy if you know how to write the script. It's the key thing here is if you look at Sprinkler data, you have the sender information, but a network requires 2 nodes. You do not have the receiver information. So you have to write code to go into that content and say, pull out the handle that tweet is directed towards and make that the recipient. And then you can say, okay, I have receiver or recipient. And then you can write 2 lines of code per network and kind of build the network out pretty quickly. A couple quick tips that I will give you in terms of data processing. Particularly if you start to build big data sets using multiple tools to analyze that data. We often use network analysis, LIWC, and a couple more to kind of build a big one. The most important thing you can do is when you download that data, create a sub-ID column and number every post, and make sure that that sub-ID column stays consistent no matter how you work with the data or how many iterations of the data you have, so that you can then use that sub-ID to pair back different data sets and merge them together and reliably. I would also say work with CSVs as much as possible. One, they take up less room on your hard drive. 2, certain softwares, for example, LIWC works better with CSVs than they do Excel files. In terms of limiting processing, CSVs are very important because they limit the processing. And then I would also say if you have to say, okay, I am not sure I need this data, or this may be too inclusive as opposed to exclusive, I would say side on the side of bringing in more data than you need. Then do you use NLP to make sure everything's relevant, rather than excluding posts that may be relevant in your data collection and your query. Always retain your original files, because someone might screw something up and you may have to go back to the originals. And finally, when you're doing your data collection and processing, I strongly suggest keep a daily log of everything you do, so that in 2 years, when you come back to this data, you don't have to remember what you did because you have it written down somewhere. Okay, so a good example of having to construct your query with this veteran suicide paper project, we had to not only did we need the clinical terms for suicide, but to really get the conversation, we need to understand what words veterans use when they talk about suicide. So we had to understand something like shotgun mouthwash is a term for suicide, right? So we had to take a big step where we collected a lot of data, a lot of conversations online, a lot of different terms, and then we ran those terms by clinical psychologists that work with veterans on a regular basis to verify them. And that whole research project was just based around building the query for what eventually became a veteran suicide study that we used to collect millions upon millions of posts. So that's kind of how difficult the constructing the query can be, but sometimes it takes a long process. In terms of data analysis, I would say this: don't overthink it. The basics are still the basics. Most of your work you're going to be doing is making sure you manage the data up front to connect to the right variables. Once you actually have your data set built, you would say, okay, I'm going to run the analysis that fits the assumptions, that the data fits the assumptions of. So use appropriate analyses for the data structure as you always would. Follow your normal assumptions. Some things that you're going to run into quite a bit with social data is over dispersion. If you think about it, if you pull a set of tweets, a lot of them are going to have 0 likes, and some of them are going to have 1,000 likes. That's going to lead to over dispersion of your data. It's also going to lead to zero inflation, which means you're going to have to do different zero inflated analyses. If you're dealing with proportional data like LIWC, that means you can't use regular regression. You have to use beta regression, right? So think about those things, and you're going to have quite large data sets. So with that, you need to know the limits of your analyses, right? You need to understand processing power, case limits, and analytical capabilities. If you're dealing with really big data sets, then SPSS, SAS aren't going to be able to handle them. You're going to have to use R, right? So understand the capabilities of the software you're trying to use. You may have to use R. Okay, so I said a lot. I hope I didn't say too much, but I'm staying under 60 minutes with these final takeaways. Social media approaches should be treated like any other research tool. Only use them if it's the right approach to use to answer the question you're trying to answer. Design and plan in a way that you can test theory appropriately. Do you need to run processing on the data that's going to give you data outputs that actually make sense with the theory you're testing? Employ data collection and processing to develop operationalizations of those theoretical concepts. What I often do, for example, I study relationships. So relationships are built on trust, and when that trust is built, you develop emotional attachment to the brand, to the person. So I often measure emotion and frequency of interaction to kind of develop trust through frequency of interaction, and then measure the emotion that results from that trust. It's a more theoretically viable way to think about trust in relationships than simply saying these people interact a lot. Coding ability is not always necessary, but it sure is helpful. I would say this: if you don't know, if you don't have those abilities, or you're not strong in those abilities, or you're a little bit worried about that, reach out across campus. I can't tell you how many wonderful colleagues I found. They're always open. They're like, oh, that's an interesting application, because they never thought about applying what they're doing to a communication context. And frankly, a lot of people from a communication point of view, when you show them what we're doing now, they're like, I thought y'all just made brochures. This is crazy. This is good research. Let's work together. So don't be shy about reaching out across campus. And finally, understand the data, ask good questions, and then do good research to answer those questions, which is kind of in everything you do in terms of research, not just social media research. So thank you so much for listening to my thoughts on the matter. I hope that I didn't completely bore you for 54 minutes. And I hope also, by the way, here's how you'll get in touch with me if you'd like. You may want to lose that at this point. But yeah, this is the lab information and my own information. But otherwise, I hope we have a really good conversation, and any questions I can answer, I'd love to. Thank you so much for listening to me.
Thanks so much, Jameson. We have a couple of questions that were posed in the questions. Kelly asks, you mentioned that sentiment isn't reliable, but what if there's a large gap between positive and negative? For example, she just ran a quick query on Roe versus Wade, and Sprinkler shows that almost 95% of the posts are negative. Is that more reliable than a 50-50 split, or would it still be difficult to depend on you publish?
Yeah, I would say that's going to depend on your outlet as to how people are going to respond to that. I would think, things that are super polar is going to be a lot easier, but still within that 95%, how much of that is accounting for sarcasm. So I would still say if you work in an area where people are super up on methodology, they're still going to ask that question. That being said, just as a layman, I would say, yeah, I'm more confident in 95% split than say a 50-50 split.
Kelly, did you want to ask your other question?
Yeah, and I'd love to just follow up on that too there, Jameson. So for example, if I wanted to sort of show more confidence in the 95%, could I say pull like 10% of the post and sort of manually look at them to verify that 95%, or how would you recommend sort of making that argument?
Yeah, I think that's a good approach because if you're going to do ideally, what I would say do is do a whole research project that's comparing the AI post to a human coder, which is what we did in the other project, and then kind of establish for all your projects that we can trust this AI. But in a vacuum like that, that's at least one way to try to help convince the reviewer. Look, I did an analysis. This is what I would do for content analysis, and we saw this % of agreement with the AI post. I think that's at least making a stronger argument, in my opinion.
Okay, awesome. And so my second question was about R. So you mentioned using R, I think, for scraping and analysis, if I heard you correctly. Have you ever used Jamovi, the graphical user interface on top of R, or do you just use like the hard, and I say hard, but like manual coding?
I use manual coding. I should have pointed out, Python is easier for scraping, is better for scraping than R is. R is really good for analysis and visualization, but in terms of data management and scraping, Python's better. You can use R for both, and frankly, I do use R a lot just because most people like Python better. I like R better in terms of just the language being easier for me to remember. So there are some slight differences. I have not used things like RStudio. My doc students have, and they like it. I just learned, full disclosure, I learned taking a class from Dr. Brian Britt, who was on earlier. And Dr. Brian Britt is hardcore. Like, he's the guy that teaches statistics by teaching you how to do the statistics by hand because he's a statistician, and he's the same way with R. So I just learned using the quote unquote hard coding. So I've never went to some of the easier things. Yes, Dr. Hassan also was taught by Dr. Britt, and he is really good. So the short answer is no, I never use those, but I've heard that they're very useful. In fact, Hassan, who is just talking in the chat, uses RStudio, so she can probably speak to you about that a little bit.
Awesome, thank you.
Great. Miaho Hong, would you like to ask your question?
Yeah, thank you for the great presentation, Dr. Hess. And my question is about Look, the LWIC. Using Look can help us to perform a sentiment analysis on social media data without relying on human samples. However, how do we derive the psychological meanings, like the motivation from test-based social media data?
Well, I would say a couple things. First, on Luke, be careful about using Luke for sentiment analysis too, because Luke was also part of that paper that we found it wasn't as accurate as it wanted to be. Now, that being said, they just released Luke 22, and they have a new dictionary, probably as partially as kind of responding to those criticisms. And it has a more robust emotion dictionary, but it still needs to be tested. So be careful with that. In terms of the psychometric value, I strongly suggest going to Google Scholar and looking for Penny Baker's work on psychometric values. There's a lot of extensive work that they developed Luke, and they defend it very well, and they've validated it several times. They can explain how things like their motivation and drives, theoretically what they mean and how the dictionary tests them. So definitely take a look at Penny Baker.
Yeah, thank you so much.
No problem, Yahong.
And Brian Wang, did you want to ask your question? I saw in chat.
Yeah, absolutely. So I just came across a recent RFP from the National Institute of Justice that has that has kind of specific language saying that that it would not fund applications that propose to use social media data to identify individuals.
Mhm.
So when you talk about using social network analysis, right, to identify individuals to target our messages to, that kind of that reminded me of that language. So have you run into those type of issues when you draft proposals for NIH or for other agencies?
I would say that if they would offer us funding, we would run into those issues. We would love to have those conversations. Yeah, it is difficult because the Veterans Project, to be as useful as we want it to be, we would like to work with the DoD and say, hey, look, you need to be paying, you need to check on these individuals because they're exhibiting the telltale signs of committing suicide, or they're the individuals who need the most information. So that would be, most of that would be working with DoD projects that are secure projects that are confidential, so that we do not publish, and we wouldn't be able to publicly publish those names. If we did publish that information, we'd absolutely use pseudonyms instead of the real names, obviously, because the other part of that project is, we have another group on campus that actually has a database of veterans who have committed suicide in the last 10 years. So the hope was to pair those two data sets and be able to find the communication patterns that are predictive of committing suicide, so we can then write an algorithm to say, okay, these people are starting to show those patterns, we need to be on alert. So yeah, absolutely, that's always a good question, and something that I would love to wrestle with funding agencies on, but first they have to engage us in the conversation.
Really
Great question.
interesting.
Thank you for that.
And thank you.
Any other questions? People can raise their hands, or if you've already got a mic, you can just open up your mic. Or compliments. Dr. Hayes left 15 minutes for compliments.
No. Yeah. I'm sure I'll get a critique from my doc students who are on the call here in a few minutes. Everyone's ready to get to the drinking portion of the program.
Good job moving beyond your apparent core competency of creating brochures. I think that's really fantastic.
Anyone who has done grant work across universities have at some point had someone say, I thought y'all just created brochures in the communication college. You can do what?
That's so true. That's so true.
How long have you been doing this again, Jameson?
This meaning, yeah, I started working in social media in general in terms of branding research in my doc program. So I guess 2008. The lab here opened 4 years ago.
Okay. Because Valerie and I are feeling a bit behind.
Yeah, it's been we've had months. It's fine. We're basically we're like right there.
That's right.
You're doing a great job, and what you'll find is pretty quick people will find your lab, and then you won't have time to do a lot of the things you're hoping to do because you'll be too busy putting out research with those people.
Right.
Lance is the OG of the group. He's been running the lab.
He means I'm old. That's what it means.
Yeah,
Do you guys have
old guy?
Do you guys have any final words of wisdom before we set everybody loose?
I have
Go ahead.
kind of one comment and also another very specific question. I don't know if I should ask here about sprinkler. One comment I wanted to kind of mention about sentiment analysis is that's absolutely true. We've just run some analysis with different sentiment lexicons, and we get completely different results. One is showing kind of it's mostly positive. The other one is showing it's mostly negative, and we can tell it's because of the context. We're looking at cancer, and so one thing that I usually do with looking at any type of sentiment analysis packages to look at how they generated that lexicon. Oftentimes they generate that lexicon based on specific data sets. Some I know are based on like Amazon reviews, or those are based on specifically on political texts. Others are based on different types of text. So I think that kind of sort of restricted the generalizability of how that lexicon can be applied when it's used to analyze a different context. And so that's kind of got me really really digging into sort of the documentation about how they generated that lexicon to see if that actually is similar to the context I'm analyzing. So that's something that I've noticed. A question I have for Jameson is, you mentioned sort of when you build this bigger data set, right? In addition to the analytics we can pull directly from Sprinkler, you also mentioned you can also add discrete emotions there. You also mentioned there's also what's the other variable, influencer scores. I just wanted to I don't know if this is the right place to talk about the possibility and how do you pull those influencer scores into the original CSV or data set we get from Sprinkler?
Yeah, so I would first say that because I haven't had the time to do my own analysis and test any of the AI driven variables, so influencer score is one of those, I don't use them in my research. However, the way you would do it is you can build you can go into listening insights and build inside an extra widget called an inline editable table. Actually, Pranay or your success manager is really good at that. He can help with that and can build a table out that has the metrics for each of the posts in your data set as well. So then you export the conversation stream, you export that widget as well, and then you have the universal message ID in both, and you merge the data sets that way.
Okay, that's good to know. I didn't know that. So does that mean I can also add, so I know there's topic modeling, right? There's kind of topics, and I also add that topic label into the original data set too?
I believe so. I haven't tried that, but yes, there's several things that, because honestly, typically we would just export the data into our own topic modeling. But that's a question that maybe Pranay could answer better than I could, because I haven't actually done that myself.
Okay, I can follow up with that, but that's good to know that you can actually merge different kind of the main data set and the data from widgets there.
Exactly. And by the way, that's something that we asked Sprinkler to do for us. And also they're working on, it's not going to make this next release. Next release is going to have whole number random sampling. So we can say, give me a random 10,000. But hopefully in the future, they're going to automate that process so that you don't have to pull them out and merge them yourself. They would merge it for you. That's been the most recent ask.
Thank you.
No problem.
Yeah, that's one of the things that really attracted us to Sprinklers, the fact that Sprinklers so open to asks, you know, like they're not promising the entire world and everything, but they're definitely, you know, willing to be collaborative and try to see what they can do if researchers need something. Lance, you had a question?
Yeah, thanks for that comment. Pranay, I don't know, I see you're on, but I don't know if you're able to respond to any of those comments or questions. Maybe not.
He answered my question, Lisa, in the chat. So,
All right. Well, thanks, Dr. Jameson, Dr. Hayes. That was great. Great presentation. So thank you for doing that for sure. That was fun.
Thanks. It was fun.